Hi, welcome back to my channel. Well, in this video I'll be doing a demonstration regarding multi-environmental trials, rather the execution of algebraic procedure of analysis of variance when we are dealing with multi-environmental trials. For that I'll be using a data set which is already available on my desktop. Let us browse this data set. The name of this data set is breeding. So we'll click on this open, then it will get displayed here. Then after that, what we have to do, we'll click on this import. So we have a data set. We have a multi-environmental type of a data, where we have the first column as environment, second one is genotype, the third one is replications. Then we have some variables or the parameters on which we want to evaluate all these genotypes across these environments, and we have 5 environments in this data set. So let us create a glimpse or see the glimpse. We will use a tidyverse library first. Tidyverse library. Press on this enter. Then I will write glimpse, the name of the data set, that is breeding. Then after that I'll be using another library that is known as data, which I have used in so many videos, data explorer. Then I will try to create a data profiling report of my data set. Although we have a different kind of a problem this time, or analysis, but in order to see the report in terms of histograms, in terms of multivariate analysis or data reduction, you can say the principal component analysis, or in order to see the frequency plots or normal QQ plots, histograms or bar plots or correlation plots in the form of heat map, you can create a wonderful data profiling report by means of this library that is known as library data explorer, which utilizes this function create_report. So we'll be having this kind of a report where you can see the number of rows are 480. We have 13 variables. The first 3 are discrete, then the rest of the 10 are continuous. We don't have any missing observations. So we have a total allocation of memory, that is 54.3 KBs, and you can see 23% belongs to the category of discrete, 77% belong to the continuous, and complete rows 100%, and we don't have any missing observations. And same will be here. We have 480 observations, 13 variables. We have the first 3 are our characters, that is environments, which are 5 in number, genotypes are 32 in number, and replicate. Every genotype is replicated 3 times. Then we have these numeric variables which are 10 in number. Then we can see the band of our data is good. We don't have any missing observations. We have histograms, or we can say a univariate type of distributions. We have also QQ plots to check the normality. We have correlation across environments with respect to these replicates and across these features or variables. The density of the color here represents the strength of the correlation. The more towards the red it is more positive, or more towards the blue color is negative correlation. Then we have a plot for principal component analysis, and we can identify which of the features are important. So by this one click we will have a very good data profiling report through the application of, or through the utilization of this library data explorer. Then after that, what we have to do, we have to perform the individual analysis of variance, or we can perform the analysis of each and every variable which is involved in data set within the environment, or we can perform the combined or pooled analysis of variance across this data set. Then let us start with the first one. For that we'll be using a function that is known as ANOVA _ind. You can see it creates or performs the within analysis of variance in a randomized complete block design, or alpha-lattice design, which is a part of incomplete block design. Because in breeding experiments or breeding trials, normally we used to have a large number of data, a large number of genotypes, or we are interested to evaluate large number of genotypes, where we use to apply incomplete block designs. Because the problem with the traditional randomized complete block design is that we cannot increase the block size because we will not be able to maintain the homogeneity within that block if we are evaluating a large number of genotypes for the varieties. And we'll click on this. Then first argument is to write the name of our data set reading, comma. We'll write the first variable. The first one is environment, genotype, then rep. So we'll write the default code here. env is used, the name of the column that contains the levels of the environment, is equal to, it is labeled as capital env, then gn, then we will write it as gn, then comma rep, rep is equal to rep, it is labeled as this, then the response variable resp, we will write everything. So we want to get the analysis of individual analysis of variance of all the variables. Then what we will do, we'll type this comma, then verbose is equal to capital true, then we'll close this bracket. Let us run this. Let us see what will happen now. So we are good to go. We'll simply write now ind, then we'll press on this enter. So we'll be having the analysis of all the variables. You can see all these variables, whatever the variables were involved, because our first variable was pH. You can see the plant height, pH, then PB, the second one is PB, and the last one is this SYP. You can see we have 5 environments. We have mean of this variable within each environment. We have degrees of freedom for genotypes. We have mean square due to genotypes. We have F calculated for these genotypes. We have P values for these genotypes. We have degrees of freedom for blocks, or in this case replicates, or mean square due to blocks, or we have F calculated for blocks. We have P value for this block. Similarly, we have degrees of freedom for an error. We have mean square error. We have coefficient of variation, and the very important thing is we have the value of heritability. And here you can see the fourth environment in this variable is having a high value of heritability, which is nothing. This is the ratio of genotypic and phenotypic variance. Since we have done the analysis of all these variables, let us perform the analysis of variance only of this last one, SYP. So in return, we will again get only one ANOVA, or one mean square components of variances for only this variables. Or if we are interested to perform the analysis of variance, or we can say the pooled analysis of variance for this type of data set, because we are having 5 environments and we want to see whether there is an interaction of genotypes across these 5 environments, we'll simply write ANOVA underscore this function, that is joint. It performs a joint analysis of variance to check the presence of genotype versus environment interaction using both randomized, in this case we have randomized block design, or we have a situation where we can use alpha-lattice designs also. So we'll click on this joint only. The rest of the arguments are same. The first argument is nothing, it's the name of data, then the label of the environment, the label of the genotypes, the label of the replications. Or if we'll write response is equal to everything, then it will perform this. In this case we have to write everything, but in case of individual analysis of variance we don't need to write everything every time. So if we will write everything in case of ANOVA underscore IND, then it will get an output of component of variance for every individual variable. But if we will write the name of only individual variable, it will create us the component of variances for that variable. But in case of pooled variance or combined analysis of variance, we have to write here at everything, because we have to write in order to save the time. Then we'll press on the center. Then we are having the joint analysis of variance of each and every variable across these 5 environments. So since we have typed everything on this previous code, let us again run for only pH in this example, or this code, sorry. So let us change the name here. We will write joint only, and we'll press on this enter. We'll be having a joint ANOVA for only first variable. So we have the degrees of freedom for the environment, or within replicates or this environment than for this genotype, and we have a significant interaction indicating all the variables with the significant p-values indicate we have a presence of G into E interaction. That means genotypes are vary with respect to this pH. They vary across different environments. So only two arguments, or rather we can say we have to use only few arguments: the name of the data, environment label, genotype label, replication, and the number of response variables, or we can write simply everything, or we can simply change this IND by means of joint. We can perform the combined analysis of variance across different years, different environments in this case, or we can perform the individual analysis of variance. Hope you will like this video. If you have any questions or suggestions, you can comment on the comment section below. Thank you very much.